Hello friends, welcome to this video on Introduction to Euclid's Geometry. Euclid's definition. In this video, we will discuss about Euclid's definitions. Let's begin with some historical background related to the origin of geometry. Geometry. The word geometry originated from the two Greek words, geo and metrin. Geo means earth or land, and metrin means to measure. From this, it seems that the word geometry originated due to the need to measure land. Friends, do you think that this branch of mathematics, that is geometry, has originated recently? No, it has been studied in various forms by every civilization since ancient times. For the Egyptians, every time the Nile River would get flooded, it would destroy the boundaries of their fields. They faced many difficulties to rebuild those boundaries the same way. Egyptians developed many geometrical techniques and rules to solve these problems. Looking at the canals and pyramids, we can easily say that they used their knowledge in their construction also. And in the Indian subcontinent as well, by seeing the design and arrangement of cities such as Harappa and Mohenjo-daro found during excavation, one can realize that the people of Indus Valley civilization also had an abundant knowledge of geometry, not just by seeing, but also by reading the Vedas and scriptures. We have found evidence of knowledge of geometry. In the Sri Yantra given in the Atharva Veda, the 9 isosceles triangles connected with each other are hidden. Can you tell the total number of triangles in this figure made of triangles? These are arranged in such a way that 43 small triangles can be formed from them. We have been receiving information on geometry from one generation to the next, either orally or through written messages on copper plates. In some civilizations, such as Babylonia, India, and Rome, geometry was confined only to a subject with practical perspectives. But people of civilizations, such as Greece, showed a great interest in the arguments behind geometry. The Greek mathematician Thales first provided the fact that the diameter of a circle bisects that circle into two equal parts. Friends, you would have heard the name of Greek mathematician Pythagoras. He was Thales' disciple. Pythagoras and his comrades together discovered many geometrical properties and developed the principles of geometry. All the Greek mathematicians of that time considered geometry as the abstract model of the world in which they lived, and by looking at things around them, they developed the concepts of point, line, and plane, that is surface. They also developed some concepts from the study of solid objects. For example, solid objects have shape, measurement, and position, and they can be transported from one place to another. They have 3 dimensions, that is, they are 3-dimensional. Friends, its boundaries are called plane or surface. A surface has 2 dimensions and it has no thickness, and the boundaries of a surface are either curved or straight lines, and it has 1 dimension. That is, it is one-dimensional. The ends of these lines are points, and they have no dimension. Euclid, a teacher of mathematics at Alexandria in Egypt, arranged all these statements briefly as definitions in his book, Elements, in which he collected all the knowledge of mathematics known up to that time. He divided that book into 13 chapters and named each one a booklet. Friends, let's look at those definitions. First definition, a point is one which has no area. Here, they have not defined area. Second definition is, a line is a breadthless length. That is, a line has no breadth, but here, length and breadth are also not defined. The third definition is both the ends of a line are points. Point is where the line ends. This is the fourth definition. Line which lies evenly with the points on itself. That is, we can say that on joining many points, a line is formed. The fifth definition is that a surface is that which has only length and breadth. That is, we can say that a surface has no thickness. The sixth definition says that the edges of a surface are lines, sides, that is, boundaries. And the seventh definition says that a plane surface is a surface which lies evenly with the straight lines on itself. That is, we can say that there are many lines on a surface. Friends, there is a need to define several terms in the definitions given by Euclid, such as area in the first definition, length and breadth in the second and fifth definitions. If in the first definition we define an area by the space it occupies, then we will need to define space as well. Similarly, we get a long series of definitions without any end. For this reason, mathematicians considered some terms in geometry as undefined. Friends, that's all in this session. Today we discussed Euclid's definitions. See you in the next video. Thank you. Hello friends. Welcome to this video on Introduction to Euclid's Geometry. In this video, we will look at some examples related to Euclid's definitions. Let's start with the first question. Fill in these blanks. Look at the first blank. Here, we are talking about the boundaries of a solid. And the boundaries of a solid is a surface. Hence, the answer is surface. In the second blank, we are referring to dimension. And a point has no dimension. So the answer is point. In the third blank, we are talking about breadthless length. That is, something that only has length and no breadth. Friends, according to Euclid's definition, lines are breadthless length. So the answer is line. Look at the fourth and the last blank. Here we are talking about surface boundaries. The boundaries of a surface are either curved or a straight line. Therefore, the answer for the first blank will be curve, and for the second blank, it will be straight line. Let's see some more questions. In the first question, we have to identify the dimensions of a solid. Any solid object has length, breadth, and height. So a solid has 3 dimensions. In the second question, we have to identify the dimensions of a line. It has only length, so its dimension will be 1. Third question. Friends, we know the phases from a solid to a point. Boundaries of a solid is a surface. Boundaries of a surface is a line, and line ends in a point. Therefore, the phases will be solid, surface, line, and point. Friends, that's all in this session. Today we saw some questions related to Euclid's definitions. See you in the next video. Thank you. Hello friends, welcome to this video on Introduction to Euclid's Geometry. In this video, we will discuss some facts related to Euclid's definitions. Let's start with a question. Friends, in geometry, why do we consider a point, a line, and a plane as undefined terms? Do you know the reason? Let's understand this. According to the first definition given by Euclid, a point is that
which has no part. Here he did not define part. If we define a part by the space it occupies,
can you make or show
a point which has no part?
No, it is not possible. No matter how small a point we make, it will occupy some space. And according to Euclid's second definition, a line is a breadthless length. Here, breadth and length are not defined. Friends, can we actually draw a line which has no breadth? No, because no matter how thin a line is drawn, it will have some breadth. Similarly, according to this definition of Euclid, a surface is one that has only length and breadth. Is it actually possible to have a surface that has only length and breadth? This is also not possible. No matter how thin a surface we take, it will have some thickness. Looking at all these facts, we can say that according to the definitions given by Euclid, it is not possible to show a point, the breadth of a line, and the thickness of a surface in reality. Therefore, in geometry, point, line, and surface, that is plane, are assumed to be undefined. So friends, that's all in this session. Today, we discussed some facts related to Euclid's definition. See you in the next video. Thank you.
Introduction to Euclid's Geometry. Hello friends, welcome to this video of Introduction to Euclid's Geometry. In the previous video, we had discussed about Euclid's definitions. Today, we will discuss about Euclid's axioms. Let's understand the meaning of axioms first of all. Friends, there are generally three types of statements. One that is always true, such as the sun rises in the east. It is universally true. And the other which is always false, such as a human has 4 eyes. And the third one, ambiguous, that is a sentence that depends upon something, such as this statement. It is very cold today. It is possible that there may be someone who is not feeling cold or maybe at some place where it is not cold. Therefore, this statement cannot be classified as true or false. But in mathematics, there are only two types of statements. Either they are completely true or false, such as 4 plus 2 equals 6. This is always true. And 4 plus 2 equals 8. This is always false. There are also two classes of true statements. First, that is assumed to be true without proving that is universal truths, such as we saw, 4 plus 2 equals 6. And the second, which is proved by evidence. For example, the square root of 2 is an irrational number. And it also has two classes. First, which is used everywhere or generally in every branch of mathematics. It is called axioms. And the second, which is particularly related to geometry. That is called postulates. We will discuss the postulates in detail in an upcoming video. Here, we will look at some of the axioms given by Euclid. Let's start with a statement. If I say, Rohan has as many books as Sohan, and Sohan has as many books as Monu. Friends, can we determine the relationship between Rohan and Monu with this statement? Let's see. Suppose Rohan has X number of books, Sohan has Y number of books and Monu has Z number of books. According to the statement, Rohan has the same number of books as Sohan. That is, we can say that X is equal to Y. And given that Sohan has the same number of books as Monu, that is, Y is equal to Z. Note here that X is equal to Y and Z is also equal to Y. Friends, according to Euclid's first axiom, things which are equal to the same thing are equal to one another. So here, X and Z will be equal. That is, we can say that Rohan has as many books as Monu. According to Euclid's second axiom, if equals are added to equals, the wholes are equal. That is, if A is equal to B and C is equal to D, then if we add C to A and D to B, then A plus C will be equal to B plus D. If instead of adding it, what will happen if we subtract? Friends, think a little. Even then, will they be equal? Yes. According to Euclid's third axiom, if equals are subtracted from equals, the remainders are equal. That is, A minus C will be equal to B minus D. According to Euclid's fourth axiom, things which coincide with one another are equal to one another. Coinciding or identical, or if we say that they are the same, then they are equal to each other. Like line AB is equal to line BA, because these two names represent the same line. And in this triangle ABC, angle BAC is equal to angle CAB, because these two names represent the same angle. Before coming to Euclid's fifth axiom, let's see a simple question. Tell us how many states there are in our country, India. Yes, there are a total of 28 states. That is, India is divided into 28 states. If we look at one of these states like Maharashtra, then it is certain that it will be smaller than India because it is only a part of India. Yes, friends, Euclid said the same thing in his fifth axiom. The whole is greater than the part. If we consider India as A, Maharashtra as B, and the remaining 27 states as C, then we can write A as somewhat like this. A equals B plus C. According to Euclid's sixth axiom, things which are double of the same things are equal to one another. If A and B are equal, then their double, that is 2A and 2B, will also be equal. And the seventh axiom is also such that things which are halves of the same things are equal to one another. That is, if A and B are equal, then half of A, that is A by 2, and half of B, that is B by 2, will also be equal. So friends, that's all in this session. Today, we discussed some of the axioms written by Euclid. See you in the next video. Thank you. Hello friends, welcome to this video of Introduction to Euclid's Geometry. In the last video, we discussed about Euclid's axioms. Today, we will see some questions and answers based on axioms. Let's start with the question. Is the given statement true or false? In this, triangle ABC is congruent to triangle PQR. And triangle PQR is equal to triangle MNO. According to Euclid's first axiom, things which are equal to the same thing are equal to one another. Hence, triangle ABC will be congruent to triangle MNO. And the statement is true. Is this statement true? the area of square ABCD is more than the area of square EFGC. From the figure, we are finding that the square EFGC is a part of the square ABCD. By looking at the figures and according to Euclid's fifth axiom, we know that the whole is greater than its part. Therefore, this statement is true. Is the given statement true or false? If P is equal to Q, then half of P will be greater than half of Q. According to Euclid's seventh axiom, things which are halves of the same things are equal to one another. Here, P by 2 is equal to Q by 2, so this statement is false. Is this statement true? Read the statement carefully. Ravi has the same amount of money as Avni. Ravi bought chocolate for rupees 5 and Avni also bought chocolate for rupees 5. Now both of them have the same amount of money left. Euclid's third axiom says that if equals are subtracted from equals, then the remainders are equal. Ravi and Avni had an equal amount of money. They spent an equal amount of money. Then surely the remaining amount of money left with them will also be equal. Therefore, this statement is true. Is the given statement true or false? Angle FGH is not equal to angle HGF. If we look at the figure carefully, then both these names represent the same angle. According to Euclid's fourth axiom, things which coincide with one another are equal to one another. Therefore, these two angles will be equal, and so this statement is false. Friends, that's all in this session. Today, we saw some questions related to Euclid's axioms. See you in the next video. Thank you. Introduction to Euclid's Geometry. Hello friends, welcome to this video of Introduction to Euclid's Geometry. In the previous video, we discussed about Euclid's axioms. Today, we will discuss some facts related to axioms. Let's start with a question. Suman has 4 books and 2 pens. Madhu has 3 books and 4 pens. So tell me, how many books and pens do they have in total? Friends, Suman has 4 books and Madhu has 3 books, that is, both have 7 books in total. And Suman has 2 pens and Madhu has 4 pens, that is, they both have a total of 6 pens. Friends, note, here we added books to books and pens to pen. But can we add books to pens or pens to books? No. Only books can be added to books and only pens to pens. And not only just addition, but subtraction also. That is, only books can be subtracted from books and only pens from pens. According to the second and third axioms given by Euclid, we can say that only the same type of quantities can be compared or can be added or subtracted. To understand this statement clearly, we will see some more examples, such as we cannot add or subtract a line in any angle, nor can we compare a square with any angle. So friends, today we discuss some facts related to Euclid's axioms. See you in the next video. Thank you.
Hello friends, welcome to this session on Introduction to Euclid's Geometry. In the previous video, we learned about the postulates and its definitions. In this video, we will focus on Euclid's postulates. So let's start with the first postulate. A straight line segment can be drawn joining any 2 points. Friends, let's start with 1 point and see how many lines we can draw that pass through 1 point. We can draw infinite such lines. Now, we will follow the same process with 2 points. That is, we will draw lines that pass through these 2 points. Now, can you tell how many such lines we can draw? Friends, only one straight line can be drawn through 2 points. And even if we try to draw another straight line, it is not possible. If we draw it, it will not be a straight line but a curve. Euclid has shown this postulate in many of his works. Now let's understand the second postulate. A terminating line can be extended indefinitely. Friends, can you tell what is a terminating line? We know that a line is a straight and a series of never-ending points.
And we represent a line with arrows on both ends.
A part of a line which has no mark or symbol on either side and which ends in a point is called a line segment. And this line segment was previously known as terminating line. According to Euclid's postulate, a line segment can be extended indefinitely. That is, it can be seen as a line by extending it from a small line segment to a larger line segment, or by extending it like this. This means a small line segment can be converted into a line. The third postulate moves away from a line towards a circle. According to the third postulate, a circle can be drawn with any center and any radius. This postulate indicates that we can draw a circle with any radius by taking any center. Friends, by keeping this postulate in mind, on a piece of paper you can draw a circle with the help of a compass. We can see that we can draw infinite circles. Let's move to the next postulate. All right angles are equal to one another. Friends, this is quite easy to understand. The measure of a right angle is 90 degrees. So if this angle is made up of two sides or lines, or if it is inside any triangle, it will be 90 degree only. That is why Euclid said that all right angles are equal to one another. Friends, we need to concentrate a little more to understand the next postulate. This is the postulate. Come on, let's try to understand this. This postulate says that if there are two straight lines on a paper, and now if we draw a straight line intersecting both these lines,
Then if this straight line makes interior angles
on its one side in such a way that the sum of two angles will be less than two right angles.
if we extend the two lines in the same side indefinitely,
Then they will meet each other at a point. So friends, these are the 5 postulates given by Euclid. Friends, that's all in this session. Today we learned about Euclid's postulates. See you in the next video. Thank you. Hello friends, welcome to this video on Introduction to Euclid's Geometry. In the previous video, we studied the 5 postulates of Euclid. Today we will discuss few questions based on them and understand this topic better. So let's start our session. Only 2 lines can be drawn through 2 points. Friends, is this statement true? In the previous video, we saw that infinite lines can be drawn through 1 point, and only 1 line can be drawn through 2 points. But infinite curves can be drawn through 2 points, which are not straight lines. Therefore, this statement is false. If both the ends of a line segment are considered to be the center, and from them arc of different radius is drawn in such a way that they intersect each other, then the triangle formed by joining this intersection point and the two ends of the line segment will be a scalene triangle. Is this statement true? Friends, according to the third postulate of Euclid, a circle made with the same radius but with different centers is equal. This means circles with different radii will not be equal. So, when we drew arcs with different radii, both the lengths were different. And since the three lengths are different, the triangle formed will be a scalene triangle. Therefore, this statement is true. A terminating line or line segment AB cannot be converted to line AB. Is this statement true? Friends, according to the second postulate of Euclid, a line segment can be increased indefinitely. This means
We can extend the line segment AB indefinitely.
and an indefinitely increased line segment is a line. Therefore, this statement is false. If a third line intersects the two lines in such a way that the sum of interior angles on one side is more than 180 degrees, then the two lines intersect each other in the opposite direction. Is the given statement true or false? Friends, this statement is Euclid's fifth postulate given in a different form. If the sum of interior angles on any one side is less than 180 degrees, that is less than the sum of two right angles, then these lines will intersect on the same side. Similarly, if the angle's sum is more than 180 degrees, the sum of interior angles on the other side will be less than 180 degrees, and the lines will intersect each other on that side. Therefore, the given statement is true. Friends, let's end this video here. Today we solved some questions related to Euclid's postulates. See you in the next video. Thank you. Hello friends, welcome to this video on Introduction to Euclid's Geometry. In the previous video, we discussed about Euclid's postulates and solved some questions. Today we will discuss some facts based on the same. So let's start. Two lines always intersect each other. Is this statement true or false? Friends, you can pause the video and think of the answer to this question. The fifth postulate of Euclid says that if a straight line falling on two straight lines makes the interior angles on the same side of it, and if the sum of angles is 180 degree, that is two right angles, then the two straight lines will be parallel to each other. And if the sum of interior angles is less or greater than 180 degree, then the lines will be intersected. Therefore, this statement is false. If the right angle triangle ABC is also an isosceles triangle, and the right angle triangle PQR is also a scalene triangle, then angle ABC will be equal to angle PQR. Is the given statement true or false? Friends, look at this question carefully. Here, the focus is not on the sides, but on the angles. If you remember the fourth postulate of Euclid, two right angles are equal to one another. If you place these two triangles, one on top of each other, with angle B and angle Q overlapping each other, then you can see that the angles are equal to each other, even if the triangles are not congruent to each other. Therefore, the given statement is true. Friends, with this, let's end this video.
In this video,
We discussed some facts related to Euclid's postulates. See you in the next video. Thank you.